Hello class, today we're going to talk about lesson 5-6, slope-intercept form. Our objectives today are we can write a linear equation in slope-intercept form, and we can graph a line using slope-intercept form. So let's look at our first example. We're going to graph by using slope and y-intercept. So given the slope and the y-intercept, we're going to graph. We have a slope of 3/4 and a y-intercept of -2. So our first step is we're going to graph the y-intercept. Since our y-intercept is -2, that means we need to plot the point 0, -2. So let's put that point on our graph. Alright, step 1 is done. Step 2 is to use our slope to graph 1 or 2 more points. So our slope was 3/4, which means we have a change in y, or a rise, of 3. So we're going to rise up 3. And then we're going to run over 4. And we're going to put a point right there. Now we can keep continuing this pattern. The more points we plot, the better. But we can actually move on to step 3, which is to just connect those 2 dots. So let's do that. We draw arrows on both ends, and we are done with our first example 1a. Let's look at another example. Alright, so we're going to do the same thing, but we have a line with a slope of -2 and a y-intercept of 4. So step 1 is to plot our y-intercept. Since it goes through the point 4 on our y-axis, 0, 4, we're going to put our first point at 0, 4. Then we're going to use our slope, change in y over change in x, our rise over run. Because this rises -2, we're going to go down 2. And since it runs once, we're going to go over 1. And we're going to put our next point right there. Now we can keep doing that. We're going to rise down 2 and run over 1 to plot our next point. And the more points we plot, the more accurate our graph will be. But we can stop at 3. So now we can move on to step 3 and draw a line through the points. That's not good enough. We put arrows on both sides, and we're done. Alright, let's move on. So all equations that are linear can be written in slope-intercept form. So if we have a line and its slope is m, and a y-intercept which we can call b, then we can write the equation of that line in the form y equals mx plus b. And this form is slope-intercept form. And just a little review, we have standard form, which we've also talked about. Standard form is in the form a times x plus b times y is equal to c. So we can put something in standard form into slope-intercept form by simply solving for y. So now we're going to look at writing equations that are in slope-intercept form. So we're given a slope and we're given the y-intercept. We know that we need to get our equations in the form y equals mx plus b. And the easy thing is we just have to identify each part. So m is always the slope. And b is always the y-intercept. So did they tell us what the slope and the y-intercept were in our problem? Well, they told us that the slope is 1/3, so that's m, and the y-intercept is 6, that's b. So to put this into slope-intercept form, all we're going to do is plug 1/3 in for m and 6 in for b. So the equation will be y equals 1/3 x plus 6. And that's it. We finished example 2a. Let's look at another one. So given a slope of -12 and a y-intercept of -1/2, let's write the equation. So we know our m is -12 and our b is -1/2. So we have y is equal to -12x plus -1/2, which we can simply just write it as y equals -12x minus 1/2. When we add a negative, that's the same as subtracting. And there, we've done example 2b. So let's look at another one. Let's look at 2c. So this time we have a slope of 1. So m is 1. And we have a y-intercept of 0. So b is 0. So we plug those in for m and b into y equals mx plus b. We'll have y is equal to 1x plus 0, or just simply y is equal to x. And then we're done with 2c. So let's look at 2d. So we have a slope of 0, so our m is 0, and our y-intercept is -5, or our b is -5. So let's plug those in. Y is equal to 0 times x plus -5. Well, 0 times x is 0, so we've got y equals 0 plus a -5 is like -5, and 0 minus 5 is just -5, so y equals -5. We don't have to have an mx part. All we need is a b, and it's in slope-intercept form. So that's example 2d. Let's look at example 2e. So we're given a slope of +4, and it goes through the point 2,5. So m is 4, it goes through 2,5, but 2,5 isn't the y-intercept. So we need to figure out what the y-intercept is. What we're going to start by doing is plugging what we know into the equation. We know that the slope is 4, so we can go y is equal to 4x plus b. And then we know the point 2,5. X is 2 and y is 5. So we can plug 5 in for y and 2 in for x. So 5 is equal to 4 times 2 plus b. And now we're going to solve this for b. Well, 4 times 2 is 8. So 5 is equal to 8 plus b. And to solve for b, we're going to subtract 8. 5 minus 8 is -3. And -3 is equal to b. So now we can take this -3 and we can plug it in for b. We found our y-intercept. So y is going to equal 4x minus 3. And that's it. We're done with example 2. So let's move on to our next part. So we're going to use slope-intercept form to graph. we have to write each equation in slope-intercept form and then graph the line described by the equation. So if we're given the line y equals 4x minus 3, we need to first, before we can move on to any steps, identify important parts, our slope and our y-intercept. So remember, slope-intercept form is always in the form y equals mx plus b, where m is the slope and b is the y-intercept. So we need to identify what number is in place of m and b. So our slope is going to be 4. Or 4 over 1. Our y-intercept or b is negative 3. So now we can move on to step 1, plot our y-intercept, and then step 2, from our y-intercept, use our slope to find another point, and then we can go on to step 3, connecting the dots. So let's plot our y-intercept at 0, negative 3, and then we're going to go up 4 units and over 1 unit to plot our next point. And then we can connect those dots with an arrow on both ends of our line, and we're done. Let's check out another example, 3b. So we're given the equation y equals negative 2/3 x plus 2. M, this time, our slope, is negative 2 over 3. And our y-intercept is going to be 2. So we're going to move on to step 1, plot our y-intercept. So we're going to first put a point at 0, 2, and then from that point, we're going to move down 2, and then we're going to move right 3. And we're going to put a point there. And then we're going to connect those 2 dots. Put arrows on both sides of our line. And then we're done with example 3b. So let's look at 3c. So if we're given a problem like 3x plus 2y is equal to 8, and y is not by itself, our first step is to actually put the equation in slope-intercept form. Get y by itself. So let's do that. We've got 3x plus 2y equals 8. We can lay down some train tracks to solve for y. So we're going to start by subtracting 3x on both sides. So we have 2y left on the left side is equal to negative 3x plus 8. And then we're going to divide everything by 2. We don't want to leave anyone out of the division party. So in slope-intercept form, our equation is going to be y equals negative 3 over 2 x plus 4. Now we can identify m, our slope, which is negative 3 over 2, and our y-intercept, b, which is 4. Now we can move on to actually graphing the line. So let's graph our y-intercept, which was 4. We'll put a point at 0, 4. And then from there, we're going to go down 3 units, and then we're going to go right 2 units to plot our next point. And now we can connect those dots. Ooh, that's not very straight. Let me draw that line. There we go, that's better. Put arrows on both ends of the graph. And now we finished example 3C. So let's move on to our last example, example 4. Alright, so to rent a van, a moving company charges $30 plus 50 cents per mile driven. The cost as a function of the number of miles driven is shown by the following graph. We need to first write an equation that represents the cost as a function of the number of miles. So let's start by writing a little sentence for ourselves to understand what's being asked. So the cost is 50 cents per mile driven times the number of miles plus $30. So we can now write that in an equation. If we let the cost be represented by y, is a word for equals, 50 cents we can just write as 0.5. The number of miles that we're driving we can just represent with x, so we go 0.5 times x plus 30. So our equation is y equals 0.5x plus 30. Now let's look at b. So b asks us to identify the slope and the y-intercept and then describe their meanings. So our y-intercept is 30, and the meaning of that is if we drive 0 miles, then we will have to pay a fee of $30. Our slope is 0.5. What that means is that the rate of change of our cost is 50 cents per mile. So every mile we drive, we have to pay an additional 50 cents. So now let's look at C. C is to find the cost of the van for 150 miles. So we're going to plug in 150 for x. So y is going to be 0.5 times 150 plus 30. And 150 times 0.5 is 75. And 75 plus 30 will give us that the total cost for the van, if we drive 150 miles, is $105. That wraps up Lesson 5-6 on Slope-Intercept Form. For the rest of your homework, I would like you to do the Your Turn problems when I see you when we get back to school. See you later.